This is Radio TV Phononut, and I know it's been a long time since we've done anything that receives RF energy out of the air, so I thought it was time that we do something. And this is a Sears Silvertone AC, DC, battery-operated, 4-tube AM portable radio from about 57. As you can see, it's in a nice little carry case here. Back around 1990, an elderly lady gave me one of these along with a couple other different types of radios. She was a family friend. I was a young teenager. We were over at her house one night and the subject come up about my newly acquired hobby of old radios, and she said, "Come on, let's go down in the basement and see what we can find." Now keep in mind, back then there were still lots of old people around that had stuff like this, and that generation of people didn't throw anything away. It all got shoved to the basement. In today's world, unfortunately, that generation is rapidly leaving us, and what's coming in behind it, and especially people my age, don't keep stuff like this. You know, they're doing good to keep something for 5 years before they decide it's time to throw it away and upgrade to something else. But the older people generally grew up during the Depression, and they knew what it was to get something, and once they got it, they weren't likely to let go of it. And if you go somewhere now and ask about old radios, if they even have anything, you have to hear about how valuable it is on eBay and blah blah blah. But enough of that. Let's turn it on and see what it does. And it's absolutely, completely, totally stone dead. Okay, here we are opened up, and I see one tube that's definitely gone to air, possibly 2 tubes. And you can see they have the selenium rectifier mounted to the speaker output transformer. That resistor up there is our fusible resistor for the selenium rectifier. There's a resistor there that's our filament dropper. So I think what we need to do first is address this tube issue, because it's certainly not going to play with a bad tube. Okay, before we start replacing tubes, I want to see if there's anything at all coming off of the selenium rectifier. And that'll kind of help me determine what might have happened to this set. So we'll turn it on here. With no tubes, there's not going to be any kind of conduction going on with no tube activity, so I should get full B+ off of here. Let's see what we have here. And we have a big fat 0, so I'm thinking something catastrophic happened to this radio and caused it to go poof. Let's flip it to AC and see what we have. See if we have any AC coming in. We have no AC coming in. Let's go back to our input of our surge resistor. Interesting, nothing on either side. Well, this could explain why we don't have anything. Talk about my dumb mistake for today. Had the wrong power cord plugged in. I had the power cord for the radio plugged in and not the cheater cord plugged in that I have connected to the radio. Okay, so let's try that one more time. Power on. Keep our eyes on the meter. Let's see what kind of DC voltage we have here. And we still have absolutely nothing. Alright, let's flip it to AC. Let's see if we have any AC coming into the rectifier. Not what I'd expect. Let's go back to the input of the resistor. Yeah, still hadn't got enough to say we've got anything. There we go. Our power plug just wasn't making good connection. We seem to be having a hard time with power plugs today. Okay, AC is going into the selenium rectifier just fine. Let's flip it back to DC and see what we have coming out. 150 volts coming out, and that's what I'd expect to have with no load. And you want to be careful with these types of sets. Make sure the capacitor is discharged, because with no tube conduction, the capacitor is not going to bleed off very fast, and you don't want to get a nasty shock. So you can see me bleeding it off here. You can see it bleeding down here. So, well, oddly enough, both the 1U4 and 1U5 had open filaments. Both of them are creamy on top. So I robbed them out of this GE radio. You might remember this one from a few years back. We did a video on it. The one that had a cracked circuit board and several other problems. And it was easy to get to. Alright, now let's turn this radio on and see if it works or if it blows the tubes again, or what happens. Well, nothing. Now I already see a problem, cracked hunk missing out of the board here. And this is our filament pin. As you can see, it comes right on down to here. To this point, big hunk missing, and it goes along here. Well, it's kind of hard to make connection when this big hunk is missing, so what we're going to have to do is just run a piece of hookup wire from point A to point B and see what that does. And you can also see it's cracked across here too, but doesn't appear to be any kind of electrical traces here, so this is really no big deal. We might reinforce this just to be on the safe side, since the crack is very close to it. Okay, we have our brake jumped out, and let's turn it on and see if it works or blows up. And it still doesn't work. Okay. So now I think it's just time to make voltage measurements down the filament string and see if we can find out where the break is. Okay, it's looking like our filament dropping resistor is open. On the input side, we have 154 volts. That's the DC coming off of the power supply. And if I move over here to the other side of the resistor, I have absolutely zero. Even when I turn my meter down to the 2-volt scale, I have 0.005. That's close enough to zero to be zero. And I'm on the 20K scale on my meter, and this resistor is wide open. This is called a flex ohm, because obviously it's flexible. And they use these in these portable radios because they could get them in a tight spot and bend them where they needed to be without them touching anything, because these get awfully hot. Well, they don't make these anymore, so some way or another I'm going to have to figure out how to mount a regular wire wound power resistor in here. Okay, we need a 2K ohm resistor. A 2.2K will suffice. It's something along the lines of 10 watts. That's what we used in the GE. But before I go digging through my resistor stash, I'm going to make a continuity check down the filament string and make sure everything else is still, has continuity before we go any further. I want to be able to put a resistor in here and hopefully get some action. Okay, we have 48 ohms across the filament string, and it looks like there's another smaller resistor in series with it, so that accounts for the high value. I can pull one of the tubes out and the resistance goes up to open. So let's find a 2.2K ohm resistor, even if I have to cobble something together for temporary measure until I can get the proper thing and then at least get the radio playing. Okay, I found a couple of resistors in my stash that someone wired in parallel, and they just happened to read 2.1K. That's within range of what we need, so we have it temporarily in the circuit. Let's turn it on and see if it see what happens, if it works or does nothing or blows up. And it appears to still be doing absolutely nothing. So let's see what voltage we have here. Alright, going into the resistor we have 94 volts, so something's working. It's a lot lower than it was before going in. Alright, what's coming out here? 4 volts coming out. I don't think that's quite enough. Could it be that the selenium rectifier is weak under load and not providing enough B+? Therefore, if we don't have enough B+, then we're not going to have enough filament voltage, because the filament gets its voltage from the B+, and yeah, 93.8 going in, 4 volts coming out. So I don't think that's enough. That's not enough filament voltage. Yeah, what we need here is 7.5 volts for the filament, and then only 4 is not going to get it. So I think what we need to do is find a silicon diode, come up with the appropriate dropping resistor to put in series with said diode, and the record players and stuff that we've been doing in the past, the B+ is really not that critical. In radios like this, it's more critical, because if the B+ is running too high, your filament voltage is going to also be running too high, and that could cause the tube filament to burn out. So if it wants 7.5 volts, we need to get that voltage as close to 7.5 as we can get it. Okay, I'll replace the diode, and I'll just have it jump, no resistor, and we're up to 5.2 volts now. That's still not enough, so something's going haywire here. Right, 94 volts on one section of the filter. 110 on the input section, and this other low voltage section for the filament only has 3.9 volts on it. I wonder if that section is possibly leaky and loading us down. And by the way, you've noticed so far I haven't replaced one capacitor in this set. If this was one of those sets that I'd have just gone through and replaced all the capacitors, I would have been very disappointed at the results, because it would have been absolutely nothing, because this resistor would have been wide open. And there again, that just illustrates a point that me and Shango 066 have made plenty of times, that yes, often capacitors need to be replaced, but it's not the be-all, end-all instantly getting your radio to work 100%. There's usually more to it than that. It's been my experience that a bad capacitor usually will not just kill a set, make it totally dead. It'll usually work to some degree. It may hum, it may squeal, it may do other undesirable things, but it'll still work to some degree. When a set's totally dead, there's usually something else wrong with it. Alright, I'm here checking voltages and running some more tests on the audio stage. Not getting any kind of buzz at the control grid of the first audio tube, so none of that's working. I've tested the speaker and output transformer, all that's good. I'm on pin 2, which is the plate of the first audio tube, and I'm getting, how much am I getting? 16 volts. I would think that would be a little low, even for a battery tube. I would think it should be higher than that. Yeah, they're saying typically 67.5 in the tube manual with 100 volts maximum. The battery in these types of sets is usually 67.5, so that's where that figure is probably coming from. But we're only getting 15 volts, and it looks like the plate comes out of this couplet here. And that big brown long thing is the couplet, and that looks like the ones that are used in some of the old Philco televisions that go bad, so this one could very well be bad. I think what I need to do now, instead of guessing, is try to dig up a schematic on this radio, and then we'll have something in black and white in front of us to go by. But I'm betting this is probably bad. Alright, I'm checking the internal resistance, which feeds the plate of this tube, coming off of the B+ line through the couplet into the tube plate, and I'm reading 1.4 meg. That sounds a little high to me, but like I said, I think I need to just go dig up a schematic and quit just playing guessing games here. I can tell you the one I was given back in 1989 or 90 was not this involved. I think all that was wrong with it was there was a trace broken on the circuit board where the oscillator coil is. And I didn't really know diddly squat about radios then. I remember my father taking it to an old TV shop, and they looked at it and told me that all the tubes were very weak and the tubes were no longer available and that the radio wasn't worth fixing. So he brought it back home to me, and I decided, well, I don't have anything to lose, so I played around with it and just happened to find that broken trace and jumped a wire across it, and the radio played perfectly. I don't even remember what happened to that radio, but it was a little different than this one. It was in a charcoal gray case, and the speaker grill on mine was perforated metal, while this one's plastic. And if we look at the control grid of the audio output tube, I would think we should see a negative voltage there, but we're not. We're seeing a positive voltage, about 1.1 volt, and that could be due to the internal capacitor in this couplet being leaky. So everything I'm looking to, this couplet does seem to be bad, so we probably need to get that squared away, and then we can deal with our possible lower filament voltage. Get the couplet replaced. It's possibly causing the output tube here to place just a wee bit more load on the power supply than it should because of this positive voltage here, and our B+ might come up just enough to give us the right filament voltage. Alright, I didn't find the schematic for this radio, so I just used the generic schematic out of the back of the RCA receiving tube manual, and it says our grid bias resistor for the output tube should be 1 meg ohm. We're reading about 4 meg ohm here, so that's gone up. We've already determined that our coupling capacitor is leaky by the presence of positive voltage on the control grid. And our plate supply resistor for the first audio tube is supposed to be 220K. This is 1.4 meg, so yeah, a lot of inconsistencies there. So I think what we're going to have to do is just pull this couplet out of here and just rebuild it with standard components and see what happens. Alright, here it is now. I think I really would like to find the proper schematic for this radio so I can make sure we're rebuilding this properly. And it's going to be a time-consuming process. I'll just have to rebuild the new one on a piece of phenolic board and stick it in there, but at least when that's done, I don't think we'll ever have to worry about it going bad, or at least not in my lifetime. Now, I checked the coupling cap section of the couplet, and it leaked at 600 volts, but below that it was fine. However, this other cap that I replaced, it's a bypass capacitor that connects from one side of the filament line to ground, a 0.1 at 200 volts. One of these good all plastic case jobs that was supposed to be an improvement over the old wax paper capacitors. Well, as you can see, it what's this thing rated at? 25 volts? Is that the, yeah, 20 volts? Leaking like crazy. So yeah, that one's shot. Of course, replacing it didn't bring our filament voltage up any, but still, anything that leaky needs to go. Now, I could have swore I had already checked the section of this filter capacitor that's in the filament line. It's supposed to be 100 microfarad, reading 7, jumping back and forth between 7 and 8. The high voltage section is checked fine, but this one doesn't check so fine anymore, so let's just go ahead and replace that. Well, I don't know what was going on with that filter cap, but replacing it did nothing. We still have 5.45 volts, and of course I put the old couplet back in here, so I guess now it's going to come back out and get rebuilt, and we'll go from there. Yeah, still 17 volts on the plate of the first audio tube. Get this out of my way where I can see what I'm doing here. That resistor's getting hot. Yeah, we don't need you melting the .96 on the control grid of the output tube. It was over a volt before, so it's possible that me heating the thing up with a soldering iron caused its properties to change, and that's the reason our voltages are now a little different. Okay, we got the schematic for the Silvertone radio, dug that up. I should have dug it up to start with because I could have saved myself a whole lot of guessing. Well, looking at the plate of the 1U5, it's actually supposed to have 15 volts on it and 10 on the screen grid. However, if we look down here at our AC input to the selenium rectifier, find it on here. Supposed to be a 100 ohm 3 watt resistor. That resistor is reading 180 ohms, so that might be choking us down enough to cause a problem. Okay, I'm now back to this couplet thing here. It's supposed to be 3.3 meg from the control grid of the output tube to ground, but we have, let's see, when this meter settles down, 4.4 megs, and we're getting a bit of a positive voltage on the control grid here, so I think we're going to, for now, just eliminate this part of the couplet with a capacitor and a resistor and see what happens. I feel like such a moron. I feel like the grand moron of the year. It helps when you have the correct tube plugged into the socket. I thought I had the 3V4 out of the other radio plugged into there, but it turns out I had a 1U out 4 plugged in there, so that could explain why it wasn't working. But obviously we still have problems, but at least the audio's working. And to think I wasted all this time and had the incorrect tube plugged in. Sounds like our 1R5 is extremely microphonic. Well, let's change that one, and this time let's see if I can grab the right tube this time. Okay, that does say 1R5 on the tube out of the GE organ donor radio.
As I told you, there was a Harvard study that was released in January, February that actually
that's a lot better.
1,000 people died because of the hurricane. But again, it was a statistical look at the island. It wasn't actually counting.
So,
this person died
the lesson from all this is pay attention to what you're doing, and even when you've been doing this for decades, you can still make mistakes by not paying close attention. And as you can see from this video, that'll cause you to run in circles. Okay, this tuning condenser has a severe case of shorted plates. We're going to have to run a thick piece of paper through the plates and see if we can break them up.
George Bush screwed it up, and we had a lot of brought to Shanghai. What?
looking through my junk to try to find something to replace that flex ohm resistor. I found a 1.2K 10 watt and an 800 ohm 10 watt, wired them both in series, and that gives us 2K ohms right on the money. Now, if we can just fit this into the circuit board without it touching anything, we'll be in good shape. There's WSM barely coming in and fading out.
Smells around like a roaring lion. Whether it's a flag football player who rolls reactions because they do, in fact, saying, hoping you'll mail it back. Tragically. Tom and Bill, they were dreadful. They fabricated them up. The water line is a national...
That's local.
The town Democrat who wants it.
I see WNBN 1290's off the air again. You may recall a number of videos back, they were off the air, and I found out that the FCC canceled their license because apparently when the original owner died in 2011, they failed to file the necessary paperwork to get everything changed over, and when it come time for license renewal, they tried to file under the old owner's name that had passed away, and the FCC canceled their license. Well, they ended up going back on the air. I don't know whether that was legally or whether they had applied for some sort of extension to try to get their problems straightened out, but they don't appear to be on the air right now.
Dr. Savage, I think you're more powerful than you give yourself credit for. I think if you have your people, your audience, use DuckDuckGo, you can make the competition something of value.
I don't even know what...
Okay, I ended up getting these hot power resistors in here. The only thing I don't like is they're a little bit too close to the electrolytic filter capacitors, but there's really not a whole lot I can do about that. And had I left the original can in here, I wouldn't have been able to get those in there at all. So sometimes you just have to do what you can do to make this stuff work and live with it. Now I've got to re-epoxy this where it mounted right here to this speaker stud. Plastic broke off. Yeah, the values of some of the components inside the couplet have drifted up a little bit. Am I going to worry about it? Nope, sure not. You know, it's really too much trouble to rebuild what's in there, and as long as it's working satisfactory, we're going to leave it alone. As is this AC input surge resistor. It's supposed to be 100 ohm. It's 180 ohm. And actually, in our case, that's working in our favor since we switched over to a silicon diode, so we'll just leave that alone, too.
Here's the curveball. It will come from...
Well, I think that's WSM. Unless there's another music station that low down on the dial that I don't know about. Or maybe that's not WSM. Actually, it looks like several of our local AM stations are off the air. 910 and 1390 seem to be the only ones on. 1010, 1290, and 1450 seem to be non-existent. Of course, it's no big loss because there's generally nothing on those stations that I listen to anyway except 1290, but there you go. I've done enough with this radio. And I hope some of you that are ticked off about me uploading so many phonograph videos are happy now. You finally get to see an RF reception device being featured.
In combat, you recently left